Hi everyone. So last time we talked about multiplying expressions with exponents, and today we're going to talk about dividing expressions with exponents. So, like last time, I wrote at the top, when in doubt, write it out. Just write out the whole expression if you're not sure where to go. So with the first one here, we have 8 over 12, and we want to simplify these. So to simplify this, I'm going to do something that you probably did maybe a year ago called factor trees, where I find the factors of 8 and 12, and I find them to be 2, 2, 2 for 8, so I have 2 times 2 times 2 divided by all the factors of 12, which are 2 times 2 times 3. So 2 times 2 times 3. And now I can cancel the factors that are common, and what I'm left with is 2/3, and that's how I simplify 8 over 12. All right, for the second one, we have a to the 7th over a cubed. And this, if we write it out, looks like a times a times a times a times a times a times a, all over a times a times a. And now I can cancel the ones that overlap. So I have 1 pair of a's, 2 pairs of a's, and 3. And what I'm left with is 4 on the top. So I have a to the 4th over 1, which is really just a to the 4th. And my third one, I have a negative exponent in the numerator, so I'm going to pull that down to the bottom, and I'm going to have 1 over a to the 7th times a to the 3rd. And if we can imagine what that looks like written out, we have 1 over 7 a's multiplied by each other times 3 a's, so I'm going to have 10 a's. So 1 over a to the 10th, and that's my answer. Okay, with the fourth one, we have 6x squared over 9x to the 7th. So I factored that one out, and I got 3 times 2 times x for my numerator, and 3 times 3 times 7x's multiplied together for the denominator. So I'm going to cancel my common terms here. I have a 3 and a 3. My 2 and a 3 don't cancel, but I have 2 pairs of x's. So what I'm left with is 2, and I might circle these to make it easier to see, 2 and 3 on the bottom, and then 5 x's multiplied down here. So I have 2 over 3x to the 5th. That's my answer. All right, for number 5, I have 2x squared all cubed over 20x to the 10th. So I have 3 2x squareds multiplied by each other over 2 times 2 times 5, that's 20, and 10 x's multiplied together. Well, I took the liberty of writing all of these out in the numerator, so I have 2 times 2 times 2 times 6x's multiplied together, and the same thing on the denominator, so I'm going to cancel my terms. I have 2 pairs of 2's, I'm left with a 2 and a 5, and then I can cancel 1, 2, 3, 4, 5, 6 of my x's. So now on the top I only have 2, and in my denominator I have 5 times x to the 4th. 2 over 5 times x to the 4th. All right, and my sixth one is 3x squared times 5x cubed over 20x to the 9th. So I have 3 times x times 5 times 3x's multiplied, all over the same thing that we had before, but with 9 x's. So I can cancel these 2 5's here, but I still have my 3, and I still have these 2 2's down here. And then I can cancel, let's see, 1 pair of x's, 2, 3, 4, 5. And I'm left with 4 multiplied together in the denominator. And I have, let's see, 3 over 2 times 2 is 4, so 4x to the 4th. All right. Okay, so the first thing I did with number 7, if you look at it, it says 30x to the negative 6th, y to the 5th times z, all over 20x to the 9th, y to the negative 2, z to the 0. So the first thing I did before I really wrote anything out was kind of manipulate these negative exponents. So if I have a negative exponent, I bring that base and its exponent to the other side. So I flipped the x to the 6th here and the y squared up to the top. And I also took this z to the 0, and z to the 0 is 1. So I just kind of took that one out. And now I can write out what this would be kind of in all factored form. So I'm going to have 3, and actually I'll speed this up here a little bit. Okay, so now I have my factored form. I have 3 times 2 times 5 and 2 times 2 times 5. So I can cancel these 2's and the 5's, and I'm left with a 3 and a 2. And let's see what else I can cancel. Well, I actually can't cancel very much because I have y's and z's on the top and x's on the bottom. So I'm going to have to leave this as it is. So what I have is 3, let's see, I have 1, 2, 3, 4, 5, 6, 7 y's, y to the 7th times z, over, let's see, we have 2, and how many x's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2x to the 15th. All right, so that's my simplified answer. Okay, number 8. Number 8, we have this expression all multiplied to the negative 2. Before I do anything with that negative 2, I'm going to simplify everything I possibly can inside here to make my life a little bit easier later on. So I wrote out 3 times 3x's multiplied together times y, and then in the denominator I have 2 times 2 times 5x's times 7y's. So what I can do here is cancel. I can cancel x, 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 and y. So I'm left with a 3 in my numerator, 2 times 2, 2x's, and let's see, 6y's. So I have 3 over 4 x squared y to the 6th. And this is all to the negative 2. So now what I can do is take this, and I'm going to flip everything and put every single term to the 2. I'm going to square it. So I'll have everything flipped. I'm going to have 4x squared y to the 6th over 3. And this is now all just squared, no more negatives. So now I can put every single term to the 2. So I'm going to have 4 squared times x squared squared times y to the 6th squared all over 3 squared. And this looks like, let's see, what do we have here? Well, we'll have 4 times 4, and then I'm going to have x times x twice. So I'm going to have, let's see, 4 x's. So x times x times x times x. And then if you imagine, I'm going to have 6 y's twice. So I'm going to have y to the 12th. So I'm just going to put that like that for now. And I have 3 times 3 in my denominator. So this is going to be, let's see, will anything cancel? I don't think so. I don't have any like terms here. 2 times 2 times 2 times 2 for 4 times 4. And I don't have any x's or y's in my denominator. So all I can do is kind of put this into exponents here. So I'm going to have, let's see, can you see this down here? Maybe not. I'm going to move this up to the top. And I'm going to have 16, that's 4 times 4, x to the 4th times y to the 12th, all over 3 times 3 is 9. So that is my simplified solution. All right, let's try a word problem, and then we'll be done. Okay, so in this problem we're told that the U.S. national debt as of January 31st, 2017 was $19,190,000,000. We're also told that the U.S. population is 318,900,000 people. And if the debt were shared evenly among everybody, how much would each person owe? So before we get into any dividing here, I'm going to convert these into using scientific notation. So my first number here is going to be 1.919 times 10 to the 10th. And this number, 318,900,000, is going to be 3.189 times 10 to the 8th. So now I can bring these down here and divide the total amount of money by the total number of people. So I'll have 1.919 times 10 to the 10th over 3.189 times 10 to the 8th. And now I can expand this with all of my 10s written out. Okay, so now I can cancel a bunch of these 10s. So I have 1, 2, 3, 4, 5, 6, 7, 8. And I'm left with, let's see, 1.919 times 10 to the 10 times 10 in the numerator, and 3.189 on the bottom. So I have I'm going to have a number, let's see, 1.919 times 10 squared over 3.189. And if we use our calculators, this comes out to about $60.18 per person. Seems kind of crazy, right? If we all paid $60.18, we would get rid of our national debt. But of course, this includes babies and children, and probably be a little more difficult than it seems. So there you go, and now you can try the problems at the bottom of your guided notes. Thank you.